Hey, good morning. So, last minute, but we are here in time. No camera today. I am doing this on the road. Um, so I guess we're getting right into it, aren't we? Did you finish up yesterday? That was a gnarly one. I can't remember who finished and didn't. Oh, I don't know if you know, but I was up until 7 a.m. Hey, Alhan, good morning. Okay, Monkey Market. Okay, similar. For each buyer, simulate the creation of 2,000 new secret numbers. What is the sum of the 2,000th secret number? Let's take a look at the input. Um, okay, not sure what that is. So, market is full of monkeys buying good hiding spots. You know lots of good hiding spots that you can sell. If you sell enough, you should be able to get enough bananas to buy the device back. Okay. Their prices are actually pseudo-random. If you know the secret of how they pick their prices, you can wait for the perfect time to sell. Oh. The part about secrets is literal. Um, each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. So, each buyer's secret number evolves into the next one, right? Then you calculate the next by multiplying the secret by 64, prune the secret number. Wait, multiply the secret by 64, mix into the number, then prune. Calculate the result of dividing the secret number by 32. Round the result. Okay, we can do these steps. Calculate the result of multiplying the secret number by 2048. But we don't know the secret, right? Mixing and pruning. To mix a value into the secret number, we do this, and to prune, we do that. Okay, we can write that as we go. After this process, the buyer is left with the next secret number in the sequence. Um, yeah, I'm not sure what the catch is so far. So if a buyer buys a secret number of 123, that buyer's next 10 secret numbers would be yada yada. Okay, so we can calculate that. I'm just gonna copy paste this in right away. Probably want to test with that. And we get day 22 in already. That's weird. I don't seem to have it. Wait, why is it trying to do day 00? Okay, must have touched my script. We can move on with this. So each buyer uses their own secret number when choosing prices. So it's important to be able to predict the sequence of secret numbers for each buyer. So the historian's research doesn't cover the initial secret number of each buyer. Okay, our puzzle input is the initial secret number. This list describes the initial secret number of 4 different secret hiding spot buyers. If you can simulate the secret numbers from each buyer, you'll be able to predict all of their future prices. Each buyers have time to generate 2,000 new secret numbers. In this example, their initial secret number and the 2,000th new secret number they would generate are that. Okay, so adding up to the 2,000th new secret number for each buyer produces, sure. And for each buyer, simulate the creation of 2,000 new secret numbers. What is the sum of the 2,000th secret number generated by each buyer? Okay, so the input is the initial secret numbers. This is initial secret numbers. And okay, give me a second. I'm just adding my input. Okay, so these are initial secret numbers. That map. I'm just gonna straight up go too long already. I'm not sure. Actually, I think that should stay an int. Okay, so each buyer's number evolves into the next secret number in the sequence. And for each of them, we want the 2,000th secret number for each of these. That's pretty straightforward. Okay, let's go up and start implementing these definitions. So to mix a value into a secret number, def mix value into a secret number. We'll just call it secret. So we calculate the bitwise XOR. So value XOR secret. Then the secret number becomes the result of the operation. So if the secret number is 42 and you mix 50, the secret number would become 37. Okay. To prune the secret number, def prune. We'll put it this way. Calculate the value of the secret number modulo this number. Okay, secret modulo. Oh, okay. And then the secret number becomes the result of that. Calculate the value of the secret number modulo that number, and the secret becomes the value, the result of that operation. Okay. Each buyer's secret number falls into the next secret number in the sequence via the following process. Multiply the secret by 64, so I guess we call this evolve, or next. So def next, given a secret. Part 1 isn't hard, but part 2 is a bit harder. That's gotta be harder, right? It's the weekend. This is the last weekend of admin the code. This is when the hard ones should drop. Okay, multiply um, multiply the secret by 64. Um, then mix and then mix that into the secret number. So we mix secret with secret times 64, and then prune. Okay. Um, round the result down to the nearest. So all this stuff happens. I just want to play around with this a bit. I'm going to do an extension on a secret number. Turn these into methods. Okay, so secret.mix secret times 64. I like that better. And then we prune. And then divide by 32. So this is after we've done this multiplying, right? Mixing and pruning replaces the value of the secret number, right? Okay, so secret number changes, and then we divide that by 32, and then round to the nearest integer. Okay. Round down to the nearest integer. Okay, so just integer division. Then we mix this result into the secret number, and then prune. Um, so we take secret 2, divide by 32, and we mix that. So secret 2 dot mix secret 2 over 32, and then prune. This is a good case for using pipes, actually. Import util. Done already. Wait, both parts? I'm still part one. I'm still just typing. I'm just still typing this out. You can do that later. Calculate the result of multiplying the secret number by 2048. No, we're gonna do it this way. Is this? I'm not sure I have the right syntax. So pipe. Oh, I guess it's just literally pipe. Okay. Um, wait, was part? Yeah. So then we take the secret. Prune, and we pipe it into the next step, which is to multiply it by 2048, mix and prune. And then we do that 1,000 times for each. So 2000th. Um, def last given secret. Um, so we're going to iterate. So we start with that secret, and then we just do next on it. Drop 2000 next, and then at this point we just map that all over secrets. So initial secret numbers dot map last, and we add them up. Hmm. Okay. It looks like we have integer overflow. We're just going to replace all the ints with longs and not think about it too much. Int with long. Okay. Um, that looks better. And then we take the sum of them. Okay. Part two. The secret numbers aren't the prices each buyer is offering. Instead, the prices are just the ones digit of each of their secret numbers. Wait, the prices are just the ones digits. Okay. So if a buyer starts with the secret number of 1, 2, 3, the buyer's first 10 prices would be yada yada yada. Just the last digit. Okay. So just mod 10. The price is the number of bananas the buyer's offering for in exchange for information. You still don't know monkey, so we can't negotiate directly. Looking at the changes in the price. The monkey only knows one by looking at the changes. We'll look at a specific sequence of 4 consecutive changes in price, then sell it when it sees that sequence. So if a buyer starts with a secret number of 1, 2, 3, the buyer's first 10 secret numbers would be that, and those are all the deltas. Okay. And when exactly do they change? The highest price will be 6, so it'd be nice to give the monkey instructions that would make it sell at that time. The first 6 occurs after only 2 changes, so there's no way to instruct the monkey to sell then. But the second 6 occurs after -1, -1, 0, 2. So if you gave the monkey that sequence of changes, it would wait until the first time it sees that sequence and immediately sell your hiding spot information. Okay, so we just want to know the 4 deltas right before the highest. Is that right? Okay, each buyer only wants to know to buy 1 hiding spot, so after the hiding spot is sold, the monkey will move to the next buyer. And if the monkey never hears that sequence of price ranges from buyer, the monkey will never sell and will just move on. Okay. You can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. Determine which sequence of 4 prices will cause the monkey to get. This is per monkey, right? Each buyer is going to generate 2,000 numbers after their initial secret number. We'll have 2,000 price changes. sequence that will get you the most bananas is -2, 1, -1, 3, sure. Okay, so what's the question here? So by asking the monkey to sell the first time each buyer's prices go down 2, then up 1, then down 1, then up 3, you get that. Figure out the best sequence to tell the monkeys that by looking for the same sequence of changes in every buyer's future prices. Okay, so just one sequence, but for every buyer, you can get the most bananas in total. What's the most bananas you can get? Okay, so let's do this first. The prices is going to be, well, we iterate on the secret, and then we take 2000, I guess 2001. We'll just leave it infinite for now. And then the deltas equals prices. Well, hold on, the prices is that mod 10. And the deltas is the sliding 2 of prices. Prices dot sliding 2. Howden boys, once you finish AOC, what type of content will you stream? Will you leak code or start building Scala projects? Yeah, I have a few toy projects I have in mind, or pet projects. I think one that'd be fun, really fun to do on a stream is I have this little Rubik's Cube library that I've worked on that's group theory inspired, so pretty mathy. Um, but I also have a Bluetooth Rubik's Cube, so I want to hook that up to the screen and be able to do demonstrations there. And another one's logic programming DSL. And I'm not huge to leak code. I like Project Euler, and I might go back through the previous Advent of Code years on stream. I'd like to get all 500 done before 2025 lands, or the 2025 season lands. So these are deltas, that map. So we have a seek, seek of A and B, and we're just going to do B minus A. And then I guess we're looking for the highest number in each of these. No, we're not looking for the highest number in each of these necessarily. We're looking for the sequence of deltas that results in the highest price. Right, so my first thought when I was reading this was that I would go slide along a series of, like a sliding window of 4 deltas until I found the highest price, and then save that delta. But no, we want total. So I think I need to make an index basically with each of these. There are only so many deltas you can have, right? There are only so many delta sequences. So we can make a map and use it to count the total price for each of those. And then we merge all of those maps. Yeah. So this is my deltas. I'm fine with that. And now we want we'll call it an index, def index, given some starting secret. Oh, good. I think I'm glad you like that idea. It would be super fun. Um, I've done that before as a conference talk, but it doesn't do it justice. it's hard to I don't know, it's hard to squeeze that into just a 30 minutes talk. And it's so much nicer. It's so much nicer to stream and answer questions than it is to give like a pre-planned talk where like you kind of have to cover all your bases. So this could be a map from, um, I guess, four tuples. So int, int. Um, to a maximum. Um, well, these are just prices we're adding. We can do this as int. Okay, I think that's fair. So we're gonna zip some deltas up with the prices that follow them. And I just need to think about what that looks like. So if we have price 0, 1, 2, 3, 4, 5, and then we're going to have deltas here made up from those. So so we have these four deltas, and it's followed by, I guess, 5, right? So we take 0, 1, 0 through 4, which is 5 of them. So the first 5 prices you can't do. Is that right? Because you haven't had a series of 4 deltas yet, even by the 5th one. Or no, is the one immediately afterwards 4? I think that makes more sense. So this 4 is what we're trying to get. And we want to pair that set of deltas. So we're going to take our deltas, and we're going to take a sliding window a size 4 of those, and we're going to zip that with the prices, and I think we're dropping 4. Yeah, so zip with prices that drop 4. Okay, and this creates this we're using to create a map. So we're going to group map. So we're going to group it by identity, which is those deltas. Actually, I'm going to take those sliding 4 and turn them into tuples. So val delta tups equals that map. So we have a seek A, B, C, D, and we're just going to turn that into A, B, C, D. Right. Seems there is a theme of giving people a break after a longer problem. I guess so. I guess so. I kind of wish the longer problem was on a Saturday instead of Friday, but oh well. Mm, a break is much needed. So we're going to take the delta tupes, uh, delta tupes, zip that with the prices dropped for. And we are going to take another, how many more prices do we take after dropping those four? Let's just limit it here. So in the prices, we have that iteration. Let's do take, I think we take 2001 because it evolves 2000 times, right? There are 2000 changes. So there should be 2000 deltas. You know what, it might be more straightforward to put that limiter on the deltas. So we're going to do deltas that take 2000. 2000 deltas. And then when you try to zip that, everything will be fine. Um, okay, so we're going to group by identity, and then we're going to map each of those sequences or each of the key value pairs. So all the key value pairs, we're just going to map to take the values. And then we've got to sum those up. So this is a group map reduce, actually. Um, no, wait, hold on. The map is within, let me see the note here. Let's make sure this compiles first so that we're getting help. What's the issue here? Sliding is not a member of long to iterator long. What do you mean long to iterator long? Oh, right. Price is given the secret. So delta's given that secret. Drop is not a member. Yeah, okay. Price is given the secret. You have to pass along the secret everywhere. Okay, now we can do our group map reduce. Let's make sure the types we're passing into here are correct. Group map reduce is not a member of an iterator. Ah, okay. Well, I guess we just turn it into a list. That's surprising. Okay. So we have our identities, okay, and then we have our map, what we do with those tuples. We get the B, and then we just sum them up. Okay, this looks good. Um, let's try that on something. So index initial secret numbers. I'm just gonna rename this. We'll just call it the secrets. Okay, secrets.head. What does this look like? Oh, are we not getting a map? Found a map of long, 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 long. Oh, okay. That's too many longs, actually. So the delta tubes, what's the type of this? Long, 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 long. Um, the deltas, I think we want the deltas to be an iterator of int. Well, the prices is going to be an iterator of int. Or, I don't know, when we do this map, we're going to map it into an int. Okay, so that should fix part of that. Found a map. Interesting. Group map reduce. So we group by the identity. Oh, right. We don't group by the identity. We group by the left-hand side. The key. We group by the key. We extract the values, and then we sum up all the values. So that's what that means there. You got enough bananas for today. Great. I'm almost there. I'm catching up. Uh, found long required int. Let's just do it. to int here. Wait, if we turn it to an int first, do we risk changing its value mod 10? I think we do. So I think we want to take the mod 10 first. So we have this price, right? And we're going to take price mod 10, and then we can do a toInt here. Because once we mod 10, we don't care. Okay, so here is one map. I don't know, let's do a for each print line. See how this is looking. Okay, so for every sequence of 4 deltas, we have things. So some of these numbers aren't very high. Let's get some of the. I want to see what the highest ones look like. That sort by the value. Oh, we have to make it a list first. Reverse rather. So it's negative value. And print each of those on its own line. 20, 20, 19. Okay, so some of these can be pretty high. And then we just want to merge all of the maps once we get these indices. So how do we do this? We're going to take all the secrets that map, get the index, and let's do a fold left. So we're going to start with a map.empty from our for tup. To our price. And then we're going to accumulate. So we have our accumulator, and then we have our new index. And what can we do? For every value in I, we just use that to update our accumulator. Okay, so I dot fold left. So we start with accumulator. And then we take set accumulator and we update it. I don't know, we're just going to shadow that variable. So accumulator, and then we have another pair. So we have a key value. And then act.updated with the key, and then the value plus the value from the original accumulator. So act given the same key. Okay, so that should merge all the maps. Val full index. And then the answer to part 2 is the highest, the most bananas you can get. So full index.values.max. We have an issue here. Key not found. Okay. We want default values. So I don't know. I'll just call this a start. Dot with default value of 0. Okay, that should do it for us. Um, it's taking a second. 2580. The way we merge maps here isn't like particularly efficient. Did I submit that? Oh no, is my internet out? Okay, my bitrate is tanking just a bit. Um, okay, that's not the right answer. Let's do some testing. Give me a second here to check on my bitrate here. It's kind of being scrappy on the go today. I'm in Boston, went to a dance tonight. Which was a lot of fun. All right, but there's not a lot I can do about the stream health, is there? Okay. Um, so we have an issue here. What is the most bananas you can get? Figure out the best sequence to tell the monkey, so that by looking for that same sequence of changes in every buyer's future prices, you get the most bananas in total. Oh, I know an issue here. An issue here is that that sequence, the monkey will stop at the first time it's seen. So when we're making this index, we can't just group map reduce. We take the first instance of each of those. Um, so let me think about how I can change it in here to get just the first one. Yeah, I think that was a remix of Pokemon just earlier. We're listening to Lo-Fi Leah, who does a bunch of video game music, just lo-fi. Um, okay, so we group we group all these pairs of sequences and a number that follows it. We group by identity, which puts everything into a list. We don't so we shouldn't reduce it at the end. So when we reduce this, we're adding them all up, but it doesn't work that way. What we want to do is take the first one. So dot head, I guess. Um, and then we ignore the other one. So I mean, given an A and a B, we just return the A, basically. Okay, I mean, not the most efficient way to do it, but I think this is going to run all the way through anyway. Really bad stream delay, huh? That's too bad. I'm thinking maybe if I change to cellular, I can get 5G upload. I'm not sure. Well, fortunately, I don't have to be streaming too long because today's was an easy one. Okay. Um, I wasn't particularly fast, but it was easy. It was smooth enough. 1500 on the dot. Yeah, yeah, very easy today. I don't even know what I want to do with the follow-up here. I may could make it more efficient, but it's yeah, 10 seconds isn't great. I'm happy enough with that. Um, oh, I did figure out what I was doing wrong in day 20, right? Was that the day? So this is the one where you can cheat. Um, so yesterday at the start of the stream, I spent a few minutes implementing my part two, which I thought was like a straightforward idea. This expand 20, uh, it's the surrounding area, but everything in that area is not going to be within 20 picoseconds. So I should actually filter on that. So we filter that the surrounding contains, sure, but what we should be doing is filter, um, given a potential 2, that distance from that dist to 2 is less than or equal to 20. Thank you, I appreciate it. Um, and yeah, I think that just worked. So I didn't need this connected by walls thing I was working on. But unfortunately, so because I didn't add this line last night before midnight, I'm now over 24 hours in one of these, which is a little bit sad, but oh well. You can't do it every day. Um, what's this count connected by walls? That's always gonna be true. Just do the size of that. Okay, so we map to, let me just refactor this slightly. Um, map cheatable, not size, and not sum. And I don't think we care about any of the rest of that. We do still have our ands 1. Okay, so I'm happy with that approach. It was pretty simple. Like, um, I don't know, not bad. Taking a step back and sleeping always, or just not being in the moment makes it feel easy, pretty easy to solve these sometimes. It's the rush of doing it at midnight, I feel, kind of makes it harder. 3 more days to go indeed. Alrighty. Well, I hope everyone can get good sleep and good luck catching up, Blue. Um, I'm on the road and I have to leave early tomorrow, so, and get my sleep. So I think I'll go find someone to raid already. Short stream tonight, but I appreciate having the company. So we have Twitch, Advent of Code. Hellhound, you passed me on the leaderboard. We haven't looked at the leaderboard properly in a while. Let's give that a look real quick. I'm not sure I know what your handle is on the leaderboard. Um, oh, hold on, this is the wrong one. Ah, I see. You're an an anonymous contributor. Nice. Wait, is that you? I'm guessing that's you because none of the other names match. Um, and the deltas. I don't think I've meddled once this season. Um, for today, I was 14th. There's some. How do you get a 3-minute delta time on this one? Man, some people are just really fast. And I kind of want to see how this has been evolving. And I want to show you something on the Scala Center leaderboard. So I've been sitting in eighth this whole time. Score per day. I bounce around. Eight is the day I did best. Who else is in here? I see Black Deep. Where are you here? Oh, you've had a few days that you kind of missed and caught up on. And Marcus? Yeah, I see the. I can see the part where you were trying to get caught up in past problems. Um, this here's a leaderboard of Scala developers. I happen to lead it, but not because I'm fast. Um, I'm just persistent. So if you look at my if you look at my per day, almost every day I'm like fourth here or something like that. I very rarely get first. In fact, I've had you can see here, like I'm first on part one plenty, and then I have these long deltas. So I've only gotten first 3 times. But that's not to put me first on here, only because I'm persistent. So staying up until like 8 a.m. last night, it wasn't 8 a.m., but staying up that late to finish gets you stars. It jumped you a lot in the global rank. Wait, are you globally ranked? Ordering by the global score. Oh, you mean in the right? Yeah. I could really use work on my deltas. I run out of steam pretty soon, like every maze day. Um, yeah, I think next year I'd like to be a little bit more competitive. Um, speed, like I just feel like there's potential. There's a lot of room for easy improvement, I think, on my part. Where I mean, I don't want to grind and study too much, but I feel like there's a lot of good low-hanging fruit where I could make myself a lot more consistent. And if nothing else, I'd like to be more consistent. So, goal for next year, I have 5 years worth of admin code to practice with. It'll be nice to go back through these. I hear 2016 in particular is kind of tough. Like it started off hard and then balanced out. Okay, where is the